Okay, this is the start of chapter 5 for Pre-Calc, and we, in this chapter, are going to be talking about analytic trigonometry, which really involves a lot of trig identities and different expressions and equations that we're going to solve and reduce and simplify. So, I guess if you want to call it formulas, we're going to have a ton of formulas in this chapter. You could see here, we already know what cosecant, secant, and cotangent are. We understand all this. Okay, this down here is the new stuff. So we have the Pythagorean identities. Sine squared plus cosine squared equals 1. Okay, and then these two down here just are derived from that. Here's your other one. Whoops, probably shouldn't write over that. 1 plus tangent squared equals secant squared, and then 1 plus cotangent squared equals cosecant squared. So we're going to come back and sort of look at these and use them as a reference to solve our problems. For example, it says find sine theta and cosine theta if tangent theta equals 5 and cosine is greater than 0. Okay, so we understand that the tangent of theta equals sine over cosine, okay? And we also understand that as a result, 5 equals sine theta over cosine theta, okay? Because the tangent of theta equals 5. Now, the problem is we don't know the sine or the cosine, so it makes it kind of difficult, all right? But if we go back and we take a look at this identity right here, that's got a tangent in it. It also has a secant in it. Now, secant is related to cosine. So, we are going to use this particular identity. Okay? Now, tangent theta is 5. So I'm going to plug in 5. And I have to square it since the tangent is squared. So that turns out to be 26. Now, if I take the square root of both sides, okay, I get plus or minus radical 26 equals secant squared theta. Now you might say, well, why'd you get plus or minus? Well, when you take the square root of both sides of an equation, you have to account for plus or minus. Now, that's where the cosine theta greater than 0 comes in. Okay, so cosine is greater than 0, which means, whoops, by the way, I screwed that up. It should just be secant theta. Okay, now what that means is that since cosine's greater than 0, that means it's positive 26. Okay, now the cosine is just the reciprocal of that. Okay, so now I come back up to here. I have the cosine now. I have 5 equals sine theta over, and by the way, that turns into radical 26 over 26 for the record. So there's our first answer. Over radical 26 over 26. Okay? So if I'm going to get sine, I'm going to multiply both sides. I'm out of room here, kind of. But I'm going to multiply both sides by radical 26 over 26. I ran out of room, sorry. So those cancel. So I get 5 radical 26 over 26 is the sine of theta. Okay? So the key was to incorporate an identity in here to help find the cosine. And we had to use secant to do it. Okay, here are some of the cofunction identities. You can see in the box there the odd-even identities. These, again, are all for our reference, okay, when we're trying to simplify these identities. So here it says if cosine theta is 0.34, find the sine of negative pi over, sine of theta minus pi over 2. Now, if you come back here and look at this, okay, now you see a pi over 2 and an x. Now x theta doesn't matter. That looks very similar to this. The only difference is theta and pi over 2 are switched. So let's switch them back. Okay. Now all I did was I just switched the terms inside the parentheses. Now, I'd love to make it look like this, where it's pi over 2 minus x. So what I'm going to do is I'm going to factor out a negative sign, or a -1. Okay? So now it looks like this. The only difference is there's a minus sign in front. Well, if I go back here, all right, it says that the sine of -t equals negative sine t. So this is now negative sine pi over 2 minus theta. Okay? But here it says the sine of pi over 2 minus x is cosine. So the negative comes down, and it's just negative cosine theta. Well, right here it says cosine theta, whoops, it says cosine theta is 0.34. So our answer is negative 0.34. So again, we're just kind of playing around with these identities and just kind of maneuvering them around so that we can get them to equal something simpler. And then in this case, we actually got a numerical answer. Okay, now it says to simplify. Now it says simplify, so we're not solving. There's no equation. They want us to simplify this expression. Now it kind of gives you a hint in the title. It says simplifying by factoring and using identities. What we're going to do here is we're going to factor out a sine x. Okay? Alright? So we factor out a sine x. Now, sine squared plus cosine squared is 1. So we can substitute 1 in for sine squared plus cosine squared. Well, sine x times 1 is sine x. Okay? So, again, you know, when we did logs, you know, we condensed and expanded and stuff like that. Well, that's kind of what this is. You know, we have this big expression and we want to kind of simplify it down to either a single trig function or something that we can't really do anything with anymore. Okay. Alright, more simplifying. Now, this problem is really this. Okay, secant plus 1 equals secant minus 1 over sine squared. Okay, so the first thing I want to do is I want to distribute up here. I want to FOIL. So I'm going to get secant squared x minus 1. Whoops, that's an e. Whoops. Okay, now again, secant squared x minus 1. So if I go back to here, okay, if I go back to the Pythagorean identities and I go right here, okay, I have secant squared right in there. Now it's not minus 1, but I could manipulate it so that it would be. Okay, so this would be tangent squared x equals secant squared x minus 1. Well, this is the numerator of our fraction now. So instead of secant squared minus 1, we can put tangent squared in its place. Okay? This is part of the simplifying process. Okay? We're trying to, you know, condense this down. So, I have tangent squared over sine squared, which is the same as tangent squared times 1 over sine squared. Okay? But tangent squared is sine squared over cosine squared. So again, we're really getting into these into terms of sine and cosine. Now, a lot of these, that's what you really want to do. Get them in terms of sine and cosine. Sometimes you can't avoid it. Sometimes you're going to have to use tangent and some other things. But as you can see here, the sine squareds cancel. And I have 1 over cosine squared x. But 1 over cosine squared is secant squared. And that's our answer. Okay? So again, with this will come practice, guys. You got to practice doing these, and you know, I'll be able to kind of help you get started. And once you get practice using the identities and simplifying and solving equations and stuff, you'll get good at it. It'll be a struggle at the start, but once you kind of get into using them and get used to it, you should get better at it. Okay. It says to simplify by combining fractions and using identities. Well, we have a subtraction of two fractions, okay, and we always want to use the least common denominator when we subtract fractions. Now in this case we have trig functions in the denominator. So what we want to do here is our common denominator is going to be cosine x times 1 minus sine x. And some of you are like, well, how did you get that? Well, when in doubt, just take the denominators and multiply them together. It's literally that simple. Okay? So, we had to multiply this first one by cosine x. So cosine x times cosine x is cosine squared x. And then we had to multiply the second fraction by 1 minus sine x. Sorry. So, take the sine x and distribute, so I get sine x plus, minus sine squared x. Okay? Now, I'm subtracting, so I'm really subtracting that whole thing. I'm going to make this into one fraction. So I'm going to take the numerators and put them together. So I have cosine squared x minus this whole thing. Okay? Now I'm going to take the negative and distribute. So now I have cosine squared x minus sine x plus sine squared x over, whoops, forgot the x in there, cosine x times 1 minus sine x. Now, cosine squared plus sine squared is 1. So this turns into 1 minus sine x over cosine x times 1 minus sine x. But the 1 minus sine x's cancel. Excuse me. That gives me 1 over cosine, which is secant. And that's my answer. So again, finding a common denominator, using identities to kind of simplify, and then out of all that, you just get the secant, which is kind of what they want. You kind of want to get it down to maybe a single trig function. Okay, now it says find all the values of x in the interval 0 to 2 pi that involve cosine cubed x over sine x equals cotangent x. Well, cotangent x is cosine over sine. So I'm just going to rewrite that right now. And what I can do is I can multiply both sides by sine x. And that literally will get rid of everything. And it will leave us with this. Okay? Now, what I want to do is I want to move the cosine x over. Okay? Make that equal 0. Now, what can I do on the left side? I can factor out a cosine. That's a 1. Okay? Now, just like any quadratic, okay, we take take each factor and set it equal to 0. So cosine x equals 0, and then cosine squared x minus 1 equals 0. Okay, well, where's the cosine 0? Well, the cosine is 0 at pi over 2 and 3 pi over 2. This is where understanding what happened last chapter is important. Okay, add 1 to both sides here, so cosine squared x equals 1. Now, where is the cosine? If I take the square root, now I have cosine x equals 1. Actually, plus or minus 1, excuse me. Okay? Alright. Well, the cosine of x, okay, when it's plus or minus 1, okay, what we're looking at here is we want to know when the cosine's positive 1 and when is the cosine negative 1. Okay, so here's our problem. Okay? The cosine can't be either. Okay? Alright? So, really, actually, here's our issue. So, let's just say, x would be 0 and pi. Okay? Because the cosine of 0 is 1, and the cosine of pi is -1. Now the problem is if I took 0 and plugged it in up for x in the original equation, our denominators would be 0, and that's no good, so it's not those. These are our only answers. Because those are the only two values of x that work for both cosine and sine. These only work for cosine. Okay, now what we're going to do for this next example is, first thing we're going to do is we're going to get all the terms on one side. I apologize that this video is long, but okay. Now, what I want to do over here on the side is I'm going to just assign a variable to sine x, and here's why. If I look at this and I take y and substitute it in for sine x, that becomes a lot easier to solve than all those signs. So what I have to do is I have to factor. So I have to have my chart over here. I have 2 on top, -2 on top, 1 over here. So I've got 2 and -1. So 2y squared plus 2y minus y minus 1 equals 0. You can see this is just old school factoring, guys. So I get 2y minus 1 and y plus 1 equals 0. So y equals 1/2 and y equals -1. Well, let's come back and now plug sine x back in for y. Okay. So when I do this, and we'll just use the interval 0 to 2 pi, okay, the sine of x when x is 1/2, or excuse me, not when x is 1/2, when the sine is 1/2. Well, let's do the easy one first. This is 3 pi over 2, okay, because that's where the sine is -1, 3 pi over 2. Now for the 1/2, okay, sine's positive in the first quadrant, okay. Here's our angle, here's theta, opposite over hypotenuse. Well, that's a 30, 60, 90 triangle, so x would be 30 degrees, or pi over 6. You can use degrees if you want to, it's up to you. Okay, I'm just going to worry about the interval 0 to 2 pi. Some problems, they make you, do multiples of it and whatever, but as long as you find the answers from 0 to 2 pi, that's fine with me. This last one is very simple. Okay, so you're going to graph cosine t, and then you're going to graph y equals 0.7. So you're going to graph those both in your calculator, and then you're going to find all points of intersection from 0 to 2 pi. Okay, so what you're going to get, I don't have the answers right in front of me, but it appears you'll probably get 2 answers, and I think, if I'm not mistaken, t is going to wind up being 0.7954 and then -0.7954. You can verify that in your calculators. But we've already done a problem like this when we had like tangent x equals 1.3. It's the same thing. Graph the left side, graph the right side, find all the points of intersection on that interval. So, That's 20 minutes. Wow. Sorry about that. But we've already covered most of this already in class, so this is just a good reference. So that's 5-1.